So what holds atoms together in compounds? Atoms are held together by chemical bonds, and those chemical bonds arise from attractions between opposite charges. Positive and negative charges are attracted to each other. We can classify chemical bonds into two categories: ionic bonds and covalent bonds. So in an ionic bond, you have the transfer of electrons. Transfer of electrons from one atom to another atom. Ionic bonds occur between metals and nonmetals. When the metal and nonmetal interact, the metal loses electrons and gives them to the nonmetal. That makes the metal become a cation because it's lost negative electrons. The nonmetal becomes an anion because it's gained negative charges. Now we have positive and negative charges on the particles, and those are attracted to each other like magnets. They stick together. So the solid phase of an ionic compound is composed of alternating cations and anions. They arrange themselves in a way that they maximize attraction and minimize repulsion. Here's an illustration of the formation of an ionic compound. Here is sodium metal. Sodium metal is a soft metal. It's highly reactive. It reacts with water. So you throw a chunk of this into a swimming pool and you're going to get a big explosion because it generates hydrogen gas and a lot of heat, and the hydrogen gas ignites and it's this big old mess. Would you want to eat this? No, because it would react with the water in your mouth and that would be really bad. Here we have a nonmetal, chlorine. Chlorine gas is toxic. You don't want to be breathing chlorine gas. So when sodium metal and chlorine gas get together, the sodium atoms, which have 11 protons and 11 electrons, will lose 1 electron each. The neutral chlorine atoms that have 17 protons and 17 electrons, each chlorine atom will gain 1 electron. The sodium atom transfers 1 electron to a chlorine atom. Now this becomes a chlorine ion. It's got a -1 charge. The sodium atom has a positive charge. Opposites attract, and they'll snap together like magnetic marbles. They don't actually make a clicking sound, but it does release a lot of energy. And then we get table salt, sodium chloride, which we routinely sprinkle on our food and ingest, right? The properties of table salt, the compound, are extremely different from the elements that compose it. Any questions? The other type is covalent bonds. We use a lot of prefixes and suffixes in science. Co means sharing. So in a covalent bond, we have the sharing of electrons between two atoms. Covalent bonds will occur between two or more nonmetals. Metals are willing to give up electrons. Nonmetals always want to gain electrons. So if you have two nonmetals together and they're both trying to gain electrons, nobody's willing to give any up, and so we can't have ions forming because nobody's willing to be the cation. So instead, they share the electrons. The process of sharing electrons between two atoms creates a bond between them. It's not unlike two people sharing something, right? In order to share something, you kind of have to come together and at least agree on stuff, right? So these are called covalent bonds. And here we have representation of these little red circles are the positive nuclei of two atoms. And so if the electron is over here, they're both attracted to the electron, but that doesn't pull the nuclei closer together. If the electron's over here, they're both attracted to it, but that doesn't bring them together. We have the lowest potential energy, the most attraction, when the electron is between those two nuclei. They're both attracted to the electron, and that's going to cause covalent bond is going to cause those atoms to stay together. Any questions? The covalent bonds, sharing electrons between nonmetals. Ionic bonds, transfer of electrons, metals and nonmetals.